Today, we're going to talk about something you've probably heard about, but may not know too much about: PFAS, polyfluoroalkyl substances. These are commonly referred to as forever chemicals, and for good reason. Stick around as we uncover what PFAS are, why they are so concerning, and how they are impacting both our environment and health. So, what exactly are PFAS? These are a large group of human-made chemicals that contain carbon to fluorine bonds and have been used for over 6 decades. PFAS are so persistent in the environment because of the strength of the bonds. They are resistant to heat, water, and oil, and they don't break down easily, earning them the nickname forever chemicals. PFAS are used in a wide range of products, from non-stick cookware like Teflon to waterproof clothing, stain-resistant carpets, and even firefighting foam. Essentially, anywhere water or oil repellents is needed, you will find PFAS. Let's talk a little bit about where it all began. The history of PFAS dates back to 1938, when Dr. Roy Plunkett, a chemist working for DuPont, discovered a compound that was resistant to heat and chemicals while investigating refrigerants. This compound, later known as Teflon, polytetrafluoroethylene, or PTFE, became one of the first widely recognized products of the PFAS family. In the 1950s, researchers began to realize the potential of PFAS. PFOS, perfluorooctane sulfonic acid, and PFOA, perfluorooctanoic acid, were developed as surfactants for a variety of industrial applications, including waterproofing, stain resistance, and firefighting foams. These chemicals were used to coat fabrics, carpets, and paper products, providing them with water and stain resistance. By the 1960s and 1970s, PFAS were widely used in consumer goods and industrial processes. The US military adopted PFAS-based foams in the 1970s for firefighting purposes, particularly at military bases and airports. These foams, known as aqueous film-forming foam, AFFF, were used to suppress petroleum-based fires. Simultaneously, companies such as DuPont and 3M began to manufacture waterproof clothing, stain-resistant fabrics, and non-stick cookware, all containing PFAS chemicals. Their ability to repel both water and oil made them ideal for numerous consumer and industrial products. Despite their usefulness, concerns about PFAS started to emerge in the late 1990s and early 2000s when researchers and environmental groups began noticing that these chemicals were not breaking down in the environment. A key turning point occurred in 2000 when the company 3M announced it would phase out the production of PFOS. This decision followed increasing evidence of PFOS contamination in water supplies and wildlife near manufacturing sites. Studies from the time found that PFOA, another widely used PFAS compound, was contaminating drinking water in communities near DuPont's plant in Parkersburg, West Virginia. In 2004, the U.S. Environmental Protection Agency, EPA, began to investigate the health effects of PFAS more seriously, launching initiatives to monitor and assess the presence of these chemicals in drinking water and the environment. A landmark study in 2016 by the EPA found that PFOA and PFOS were present in the blood of nearly every American. The EPA's advisory limits for PFOA and PFOS in drinking water was updated, with a recommended limit of 70 parts per trillion. Other nations also started regulating PFAS chemicals. In 2018, PFAS chemicals were officially classified as emerging contaminants by the EPA, meaning they would be the focus of increased regulation and research. As of 2020, the EPA has initiated a process to establish enforceable drinking water standards for PFAS, while several states in the US have taken independent action to regulate the chemicals more strictly. But what actually is PFAS? Let's dive a bit deeper into the chemistry. PFAS compounds are made up of chains of carbon atoms, each bonded to fluorine atoms. Due to fluorine being the most electronegative element, this produces a large difference in electronegativity, producing a strong ionic bond. The length of the carbon chain can vary, with short chains have fewer than 6 carbon atoms whilst long chains contain more. The molecule can even be cyclical, meaning it can form a ring structure. The most well-known polyfluorinated alkane is PFOA, perfluorooctanoic acid, and PFOS, perfluorooctane sulfonic acid. These substances are classified as long-chain PFAS because they have long carbon-fluorine chains which are stable and do not easily break down in the environment due to the strong ionic bonds. This stability gives PFAS some remarkable properties. For example, they are hydrophobic, meaning they repel water, and lipophobic, meaning they don't mix with oils or fats. These qualities make them useful in industries ranging from manufacturing to cosmetics. However, it also makes them a huge environmental and health concern, as they accumulate over time in both the environment and living organisms, as they are very difficult to break down. Now let's get to the heart of the matter. Why are PFAS such a problem? Well, because of their persistence. Due to the carbon to fluorine bonds being so strong, once these chemicals enter the environment, they stick around for a long, long time. They can contaminate water sources, soil, and even the air. This means PFAS end up in the food chain, impacting both wildlife and humans. Studies have shown that PFAS are ubiquitous. They've been found in drinking water, groundwater, food, and even in human blood and sperm. Once these chemicals get inside the body, they don't break down. They can bioaccumulate, meaning they build up over time, leading to higher concentrations. The half-life of the compounds will vary due to the chain length and the environment in which the compound is in. For example, for some of these compounds, the half-life in the human body is 5 years, whilst for others it is 8.5. PFAS exposure has been linked to a number of serious health issues. These include hormonal disruptions, immune system suppression, liver damage, and even increased cancer risk. The Centers for Disease Control and Prevention, CDC, has confirmed that high levels of PFAS in the blood can increase the risk of several diseases, including kidney and testicular cancer. So, how are we exposed to these chemicals? The most common source is drinking water. PFAS can seep into groundwater from industrial sites, firefighting training areas, or even landfill sites. Once in the water, PFAS can be carried over long distances, affecting nearby communities. But PFAS are also found in everyday products. You might not even realize it, but stain-resistant fabrics, waterproof jackets, non-stick cookware, and even cosmetic products may contain PFAS. Eating certain foods, particularly those grown in contaminated soil or processed with contaminated water, can also lead to exposure. And since these chemicals are so persistent, they can end up in the food chain, especially in fish and meat. Now for some good news. There's growing awareness of the PFAS problem, and efforts to tackle it are underway. Governments around the world are taking steps to regulate these chemicals. For example, the US Environmental Protection Agency, EPA, has set guidelines for PFAS in drinking water, and several countries have begun phasing out the use of certain PFAS chemicals. There are also ongoing efforts to clean up contaminated sites and develop new technologies to remove PFAS from water. Researchers are exploring methods like activated carbon filtration, reverse osmosis, and even bioremediation, where living organisms break down these chemicals. To sum up, while PFAS are incredibly useful chemicals, their environmental persistence and potential health risks make them a serious concern. PFAS has evolved from an industrial marvel to a public health and environmental crisis. It is critical to continue to investigate their effects, regulate their use, and find safer alternatives to protect our health and our planet. As research continues, addressing the legacy of PFAS contamination will require a concerted global effort to better understand, regulate, and mitigate their impact. If you found this video informative, make sure to like and subscribe. Thank you for watching.